Good evening, students. This is Manas, your friend and tutor. In today's session, we are going to take a look at the graphical method and how this can be basically applied. So you'll need a graph paper. You can also do it roughly, don't worry. Okay. And we are going to be finding the roots, at least one root of this cubic equation using this technique. So this is going to be fun. And I want all of you to watch this video right till the end. Stay with me. Okay. Be patient. If you want to save some time, you can increase the speed of the video. All right. So far we have learned Cardan's method for cubic equations. We've learned the Ferrari's method and the Descartes method for quartic or algebraic equations of 4 degree. Let's say you are dealing with higher power of x. In such cases, you have to resort to the graphical method, or you can also use the numerical methods. Okay. Now, numerical methods can be considered as a separate chapter or a separate branch of higher engineering math. And there you will learn certain techniques. I mean, there are multiple techniques to find the roots of any algebraic equation. Okay. So for today, let's focus on this graphical method, and you'll be learning a lot of Microsoft Excel in this lecture, right? Here we go. One thing, let me first of all remind you all of you. So far, we've almost made 500 slides for this chapter 1 only. Let me go back. Sir, what exactly is a root? What is a root? Let's say you come across this algebraic equation. You see f of x, that's a polynomial. If f of x is equal to 0, that's an algebraic equation. You plug in a certain value of x, and you observe that on putting that value of x, this function becomes 0. In that case, we say that x happens to be a root. There is other way of defining it. Let's say you draw the function. Okay. And you observe that this function is intersecting the x-axis at a certain point. The abscissa or the x-coordinate of this very point is the root. This is one more way of defining the root. But sir, how can we approach such questions? How to approach such questions? Please take a look at this now. Let's say you've got a certain function, certain algebraic equation. Okay, so the LHS part is the function itself. Let's say for a certain value of x, let's say x is equal to a, the function's value is negative. You can clearly see. And for x is equal to b, the function's value is positive. Then one thing is for sure, that at least one root lies between x is equal to a and x is equal to b. So first of all, whenever you come across any algebraic equation, try to plug in certain values of x, keep it increasing gradually, and try to work out where the signs are changing. And this is going to be your first step. Once you've got that arranged, then you can proceed. Let me elaborate on this. Okay, so that's our function. So let's say x, let's say this is f of x. Wonderful. Okay, let's say we start with 0, then we go for 1, 1, 0, 1, and then we are going to have another value as 2. So I'm increasing the value of x by 1, 4, 5, 6. Let's go until you reach 10. By the way, you can pinch on this part of the screen and it will automatically zoom in. What are the corresponding value of x? Let me demonstrate how you can apply the formula. Hit equal to sign. Okay, sir. It is this cell that we want to cube, then minus of x, then minus of 1. So mine is equal to, take this cell. What is this cell? This is, sir, A7. Shift 6 for cube minus inside the bracket, sir, this cell only, then minus 1. So I have written down the function. This is going to return the value. If you want to check, you can just plug in the value of x as 0, 0, 0, and this is going to be negative 1. Click, and on the bottom right of the cell, you see the positive sign of the cursor, okay, changing. Now you can see. Let me drag this. So I've got all the values of the function for different values of x. Now the thing that I want all of you to observe is, you watch, for x is equal to 0, the function is negative. For 1, it is negative again. For 2, it becomes positive. This is the range that I want. So now I know very well that the root is between 1 and 2. Okay, you can do the same in a piece of calculator. Let me show that to you how it can be done. First of all, let me clear all of these things. Okay, all right, so just go to mode, For table, hit 7, and now write down the function. So the function is, sir, x cube minus x minus 1, alpha x cube minus x minus 1. That's the function. Do you have another function? No, sir. Okay. Enter. You have to start with, let's say we are starting with 0. Hit 0. You're going to end at certain 10. What is the step? The interval. Sir, the interval, it can be 1. Hit enter again. Now you're going to get a range of values. For x is equal to 0, it is -1. You can tally this. For 1, it is again -1. For 2, it is 5. And you can have got all of these values. Okay. So all of these things can be obtained using a calculator also. You have to write it down, basically. Right? Okay. Now you know how to use a calculator. You could have had a different function also, g of x also, had I put in the value. Okay. All right, so. Sir, we now know that this is going to be where our roots will lie. Let me. Okay, wonderful. Our root lies between x is equal to 1 and 2. Let me rewrite this. And let me copy this here also. That is going to help me. Okay. Right, that is your function. Now you know your root lies between 1 and 2. 1 and 2. Let me increase it by 0.1. Okay, when I do that, the next value is 1.2, then 1.3. See? Okay. The function is already stored here. This is cell D7. So D7, if you just pinch your screen over to this part, done. Okay, so D7 cube minus D7 minus 1. That is x cube minus x minus 1. Right? And now what we'll do is I'll drag this, and I've got these values. Even here, if you observe, these are all the negative values. It suddenly becomes positive over here. That means the root is between 1.3 and 1.4. It could be 1.35, it could be 1.36, whatever it could be. But here our intention is to find it graphically. So let me make a plot. What I'll do is, let me select these two, and let me go for insert any recommended chart. Let me take a look. This looks nice. Okay, it has got the x values also, 1, 1.1, 1.2 and so on, and it has got the value of the function also. Let me hit OK. I think it would look like a graph if I select this version. Yes. Let me zoom out. Okay, now take a look. Wherever it cuts the x-axis, as far as this problem is concerned, I'll be explaining you two different techniques. Okay, in the first technique, we're interested in creating the graph and observing where it cuts the x-axis. So it is cutting the x-axis somewhere here. If you want to have a closer picture, let me draw a vertical line. Let me use black color. Let me increase the weight. Okay, looks nice. Now let us zoom in now. Sir, where exactly is it cutting? If you watch, once you've made the graph, yes, it cuts somewhere here. Sir, this is 1.3. By the way, this is the x-axis. Okay, the 0 line. 1.3, 1.4. And in the center, it is 1.35. 1.35, yes. So if this is 1.3, this is 1.35. This has got to be 1.31, 1.32, 1.32 or 1.33 or somewhere in between. It is very safe to assume the value of x as 1.325, let's say. Okay, your final answer should be 1.325. You can also say it is 1.32. Let me write the final answer. Right, wherever it intersects, try to have a rough value. That is going to be your root. Final answer is 1.325. Done. That's what you've got. Margin center, bold and italic. Increase the font size. Margin center. Want to highlight this? Do it. Done. So that's the first way. What are we looking forward to? We are looking forward to where the graph cuts the x-axis, and you can roughly estimate that point. In the second technique, what we'll do is take a look. This x cube minus x minus 1 can also be written as, sir, it can be written as x cube is equal to x plus 1. And we can say that this is phi of x, one function. I mean, we are making two functions from one function. This is the function f of x, isn't it? This is your function f of x is equal to 0. Okay. So from f of x, you are making psi of x, phi of x, and psi of x. Let me write it like this, psi of x. And both of them have been equated to y. Right? Okay, so how do we approach? Now, we know very well, sir, in the previous method, we have seen that one root is between 1 and 2. And that's why the answer 1.325. Okay. How do we approach here? So you have to write down your functions. Let's say you write x, then you write phi of x, go to insert. Greek symbols are here, phi. Okay. And x, done. Then you have to write psi of x, another function, psi of x. One sec. Okay. Bold, italic, looking good now. Okay. Pinch your screen onto this portion. The root lies between 1 and 2. 1, let me select the second value as 1.1 and so on. Right? Let us go until 2. That's enough. That's enough. Take a look now. What is phi of x? Sir, this is phi of x, that is x cube. So you need to cube this cell. Is equal to, select this cell, shift 6 and cube it. Enter. Okay. That's the cubed value. Secondly, over here, sir, it is x plus 1. So equal to sign, select the cell plus 1 and enter. That's how you do it. Select these two cells and then drag. You are going to have all the corresponding values with respect to this x. Okay. You have all the values. Now, your root lies between, just a second. Okay, so now that you have made this, I think it would be better if I can center this. Center. Use a different color. Okay, now try to make a plot. Select all of them. Go to insert, recommended charts, right? On the same axis for the x values from 1 to 2. Right, you have two functions to plot. One of them is phi x while the other is psi x. I think this would be a better option. As you can see, the x values are 1, 1.1, 1.2. By the way, keep on pinching the screen wherever you want to zoom in. Right, hit OK. Let me make it look more attractive using this form. Okay, the intersection of these two functions is going to return the value of x, which again will be working out as 1.325. You'll realize this very, very soon. Let me use that vertical line. Control C. So you basically learned two techniques, one of which was completely depend upon the intersection with the x-axis, while the other, in the second technique, we have converted one function into two different functions, and then we have plotted them in the specific range, and then we are watching and observing where the intersection is. You can clearly see this is again 1.3, this is 1.35, this is 1.4. So between 1.3 and 1.35, somewhere in between. 1.32, 1.33, whatever you write, or 1.325, whatever you write, your answer is correct. Again, you have got the same value, that is 1.325. Okay, so this is a slightly different method. You can see this is blue color, that's why this, and then there is this orange color, that's why this psi of x. Wherever they intersect, that is going to give you the value of your root. I firmly believe that you have now a fair idea as to how such problems can be solved using the graphical technique. Although I have used, I've calculated only one value. In fact, a cubic equation has got to have 3 values. Let us just make a guess. What are the remaining 2 values? Because as far as I can see, if you see from 0, the value of, even on increasing the value of x, nothing is changing over here. We turn negative to positive from between 1 and 2, and then all I can see is the value of function increasing. I think nothing is going to happen in the positive range. Maybe if you put the value of x as -1, -2, -3, you can get another root. Let us just make a guess. Go to mode, hit 5 for equation and 4 for a cubic equation. Let me plug in the values. X cube, a 1, b, there is no x square term, 0, x coefficient is -1, and d is also -1. Let me see what the answer is. Okay, the first answer is 1.324. What we've got is 1.325. It's a rough value. Okay. These are rather exact values which the calculator is giving. The second root is, this is, looks like a complex root, -0.66 plus. Do I see an iota? Yes, there is. That means there is a pair of, there is a conjugate pair. Okay, a complex root. The previous one was positive, this one is negative. So, anyways, one of the real root has been worked out. And yeah, that was all from my side for today. If you really find this content helpful, do give this video a like and do share it with all your friends and classmates so that they can also benefit. And if you want to keep watching videos like this, do subscribe to the Manas Patnaik channel and press the bell icon so that you don't miss any update. Thank you very much. This is Manas Patnaik signing off. Take care and have a nice day.